Hello everyone, this is Ruai PCB, your trusted PCB partner. Today we'll introduce how to use operators, addition, subtraction, multiplication, and division in coordinates and dimensions in KiCad. In scenarios that require precise positioning, besides using coordinates, sometimes you also need to move by a relative distance. In KiCad's PCB editor, you can directly use addition, subtraction, multiplication, and division operators in coordinates and dimensions, which greatly simplifies relative movement operations. Let's take a quick, comprehensive look at its various operators. For example, let's use this specific component as a clear and illustrative example. Press the E key to gracefully open its detailed properties editor, and you will clearly see the precise X and Y positions displayed within the coordinate system. Here, in this particular section, you can effectively utilize many different and distinct types of operators, each with its own unique function and purpose. Previously, we taught how to directly modify the coordinate values, but in many cases you have to calculate what the relative coordinates should be, which can be a bit troublesome. But for some movements, for example, in certain situations I know I just need to move 5 millimeters to the right, so I don't need to calculate it, I can just add 5 directly. The decimal part after that remains unchanged. Let's see what happens. Look, it moves 5 millimeters to the right, which is very convenient. Addition, subtraction, multiplication, and division are all supported. If we subtract 5, it moves back. Now let's look at multiplication and division. Multiply by 2. You see, multiply by 2. Okay, now subsequently you will then proceed to divide by 2.5. This is an important step. See, addition, subtraction, multiplication, and division are all supported. All objects in the PCB can have their relative positions offset using this method. We've verified addition, subtraction, multiplication, and division. So what is the main application of this? Most of the time, this is used after arranging the components, or when you have some components that need to be positioned relative to each other in a specific way. For example, if I place something at the corner, I need to know how far this edge is from that edge. Normally we calculate based on the center, but we also have to consider the component's length and width. Then, to calculate the center, we need to add half the size of the component to the center and then add that value. This makes the calculation a bit more complex. So let's say I can place it along the edge, because it's easy to align with these two lines. If I want to place it at the position 10 by 10, I can just add 10 to the coordinates along the line. For the outer axis, since it's on top, it should actually be minus 10. So since I already added 10 just now, I should subtract 20. This way I can place it at a 10 by 10 position with the lower left corner as the origin, without having to pay too much attention to this point. We just need to know where the origin is and whether to add or subtract, which makes relative positioning very convenient. And then there are these essential electronic components, resistors for example, especially when they are meticulously arranged in a specific configuration like this. I can also effectively utilize the displacement feature to easily and precisely maintain the consistent spacing between them. Another common and important situation is when placing numerous vias. When placing these crucial vias, we often observe that a significant quantity of them are typically used in the design process. Like this, and if you try to adjust the spacing between each via using coordinates, you'll end up with errors. But actually, we can use a very simple method. Just group the vias together. Then, for example, if I want them to be spaced 50 units apart, I can first select one and then press E. You should add 50 units directly to its y-axis coordinate value. Adding 50, well, that's a bit too much. 50 millimeters is way too large. It moves it right out of place. Let's redo this process. Let's instead use a significantly smaller numerical value and then proceed to add exactly 5 to it. Then for the next one, we add 10. This way, you can very conveniently and quickly distribute the vias at equal intervals. This is also a very common usage because, as you can see, there are often many vias on a board, and if you don't distribute them evenly, it will look unattractive. Using operators to manipulate coordinates and dimensions allows you to efficiently solve the problem of relative displacement between objects. making our designs more flexible. Alright, that's all for today's content. If you enjoyed this video, please subscribe to my channel for more videos. Thank you, everyone.